Equations is a phenomenally important topic towards the end of GCSE maths and all the way through A-level maths. And there are three basic methods. You can solve a quadratic equation sometimes by factorising. Solve it by formula. Do it by completing the square. These two methods, the formula and completing the square, are actually one and the same thing, but it just doesn't look like it. Now, factorising is the simplest method, the quickest method, if it can be done. Let's look at an example which does work. Let's try this. X squared plus 9x equals negative 20. Right, the first thing that you need to know is that whenever you're solving a quadratic equation, you definitely need it to equal 0. It absolutely must equal 0. And so my first step here, because I know that about quadratics, my first step is automatically to rewrite it in the required form. If you don't do that, then it's painfully obvious to the reader that you don't have a clue what you're doing. You must have it equal to 0. Now, you should know how to factorise a quadratic. X times x for the x squared. 20 has a number of pairs of possible factors, but a little bit of thought guides you towards 4 times 5. Because not only does 4 times 5 make 20, it can also, by addition, 4x, 5x, it can produce the 9x. We know the signs are going to be the same, positive times positive or negative times negative, but we want a positive 9x, so I need a positive 5x and a positive 4x. Now it's at this stage that it becomes important that you have it equal to 0. We have a bracket multiplied by another bracket equaling 0. The only way that 0 can be the answer when you've done a multiplication is if one of the things that you're multiplying by is 0. So we know that either x plus 4 equals 0, perhaps x plus 5 equals 0. Take 4 off each side, x equals negative 4. Take 5 off each side, x equals negative 5. That's factorising. I should maybe just mention that within factorising you've also got much easier questions. You've got questions such as x squared plus 3x equals 0. This is easier because it doesn't have a number term. The factorising is much more straightforward. And so we discover that x equals 0 or x plus 3 equals 0. And so x equals 0 or negative 3. You've also got situations where there's no x term. So you have things like x squared minus 25 equals 0. And you need to recognise that as the difference of two squares. You see factorised to there. And so x plus 5 equals 0 is one option. X minus 5 equals 0 is an option. And so x equals negative 5 from there. X equals 5 from there. So these are all achieved by factorising. Now, the formula. Suppose we had x squared plus 5x plus 4 equals 0. The formula says that x equals a fraction where the numerator is negative b plus or minus the square root of b squared minus 4ac all over 2a. And you need to understand that a, b, and c are the coefficients of x squared, b, and then the number term respectively. So we know that a is equal to 1, b is equal to 5, c is equal to 4 for this particular question. So it follows then that x equals negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2a. X equals minus 5 plus or minus the square root of 25 minus 16 all over 2. X equals minus 5 plus or minus square root of 9 all over 2. It's worthwhile just taking a moment to comment on this square root of 9. The contents of the square root, b squared minus 4ac, is known as the discriminant. I'm not going to discuss it in detail here, but it's important that you understand all the different things that the discriminant can tell you. One of them is that if it produces a square number, as this one does here, 9 is a square number, then that tells you that actually the quadratic could have been factorised. So I'm not using the best method here. I'm just doing a simple example. Second thing is to say, some questions will tell you to leave your answer in third form, or an exact value. So if this hadn't been a square number, if this had been 8 instead of 9, then I could legitimately have left my answer as negative 5 plus or minus root 8 all over 2. That would be a reasonably acceptable answer. In this particular case, though, I need to tidy it up. Minus 5 plus or minus 3 all over 2. And at this stage, you should split your answer into two columns. One for the positive 3, one for the negative 3. And so we've got, what's that, minus 2 over 2 makes minus 1, and minus 8 over 2 makes minus 4. So that's the quadratic formula. You need to be careful with negatives if you get a question with negatives in it. But that's your second method. Completing the square. Again, I'm going to do a simple example just to illustrate the point. Completing the square. Let's suppose we had x squared plus 6x plus 8 equals, no, let's change that, minus 8 equals 0. If you complete the square, you're going to get x plus 3 all squared minus 9 minus 8 equals 0. X plus 3 all squared minus 17 equals 0. Watch my video on completing the square if you don't understand how that's been done. But now I can basically make x the subject. I can add 17 to both sides. I can choose to square root both sides. And let's remember that when you square root something, normally we just state the positive answer, but technically it's always a plus or minus. The square root of 9, for instance, is actually plus or minus 3. We saw that happening in the last example. The square root of 9 is plus or minus 3. And now I can take 3 off each side, and I've got a nice exact answer. Which actually I can just leave like that. Those are your three methods for solving a quadratic equation, and you really need to become fluent in all of them.